All right, so we're going to go ahead and move on to the next section. We are going to be covering operations with complex numbers. So just like we built up going over synthetic division, the quadratic formula to get into the more difficult stuff, we're going to do the same thing here. So we're going to start off by building with our operations with complex numbers. Okay, so we're going to review a few things. We have our imaginary unit I. And so I equals the square root of -1. Now we know we can't take the square root of a negative number and get a whole number, so that's why they created the little I to be the same thing as the square root of -1. So if I equals the square root of -1, then if we were to square I, remember if we square I on this side and we square it on this side, then we get I squared on the left, and the squared and the squared cancel out, and it gives you -1. Okay, so this is one of the key things that we need to remember is that I squared, wherever we see an I squared, we always got to replace it with a -1. Now, a complex number is a number that can be written in the form of A plus BI, where A and B are real numbers and I is equal to the square root of -1. So you'll have a real part, which is A, and you have the imaginary part, which is BI, and that is called a complex number. So here it says perform the operations and simplify. So I to the third power, we're going to rewrite it as I times I times I. And so we know that I squared, these two right here, is going to give us -1. So instead of I squared, I'm going to replace it with -1. And then I'm just going to drop down that I there. Okay. Let me erase that. It's bothering me. Okay, then we multiply -1 times I is just going to be -I. And that's it. So let's go ahead and look at the next one. Here we have I to the fourth power, so we write it as I times I times I times I. And remember, I squared, so two of these, I times I and I times I, are equal to -1. So this is equal to -1 and this is equal to -1. So -1 times -1 would give us a +1. Okay, let's try the next one. We have I to the ninth power, that's going to be equal to I times I times I times I times I. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So then remember, every I squared is equal to -1. This one is also equal to -1. This one is equal to -1. This one is equal to -1. And then we still have an I left over. So -1 times -1 times -1. Well, we know two negatives make a +1. So it's 1. These two negatives would make a +1. So +1 times +1 times I would just give you I. And that's it. All right. So here we have 4I to the third power. So 4I to the third power. Remember the rules for exponents. Not only does a 4 have to be placed to the third power, but so does the I. It has to be placed to the third power. So you distribute the 3 to each one. So in our calculators, we could just do 4 to the third power. That gives us 64. We break down the I to the third power to I times I times I. And we know these two i's are going to give us a -1. So 64 times -1 times I is going to give us -64I. And that's it. So let's try the next one. This one's 2I to the fourth power. So not only do we have to put the 2 to the fourth power, but we also have to put the I to the fourth power. Now 2 to the fourth power, if we put that in our calculators, that gives us 16. And then we break down the i's. I times I times I times I. Now we group them together. Remember, for every two i's, that gives us a -1. These two give us -1. And two negatives make a positive. So 16 times -1 times -1 is going to give us a +16. Okay, now I plus 6I, you kind of use the same rules as x's, okay? So if you have one x and you add 6 more x's, you're going to have a total of 7 x's. but we don't have x's here, we have i's, so 7i. Okay, so the rules are a lot like adding and subtracting variables. The only difference is if you ever see an I squared, you gotta substitute that for a -1. So for example, here you have -3i's and you add 1i. So it would be like adding x's. So -3x plus 1x would give you a -2. Okay, here, just like x's, you can only combine like terms. So -1 and -4, you can combine those. That gives us -5. Okay, then you add your imaginary numbers. -8i and -i is going to give us -9i. Okay. The next one here. So here, before we do anything, because we see this negative out here, we do need to distribute the minus to each one. Okay, inside the parentheses. So we have -3 plus 6i. A negative and a negative would make that a +5. A negative and a -3i would give us a +3i. And you do not distribute the negative to the 8i because it's not inside the parentheses. Okay. Then we go back to the same thing. We combine our like terms. So we combine our real numbers. Our real numbers are -3 and +5. Together, that gives us 2. And then we combine our imaginary parts. We have a +6i, a +3i, and a -8i. So 6 plus 3 is 9, minus 8 would give us a +1i. And remember, just like the rules with the x's, you do not need to write the 1 in the front. It is invisible. So that's it. Okay, let's look at the next example. Here we have 4i outside of the parentheses, so we would have to distribute that 4i to each one. So 4 times -2 is -8i. 4 times -8 gives us a -32. And then I times I gives you I squared. Okay. Remember, the rules are exactly the same as x's. The only thing is, if you ever see an I squared, you have to replace that with a -1. So -8i, we have -32, and instead of I squared, we write it as a -4. Well, -32 times -1 gives you a +32, so plus 32. That's it. So the next one here, we have 5i times -2i. So looking at the coefficients first, we multiply the numbers first. So 5 times -2 gives us -10. And then remember, if you have an I times an I, that's an I squared. That gives you -1. Here we just have this I that's hanging out by itself. -10 times -1 gives us a +10, and then we have that. That's it. Okay, let's look at the next ones. How many more do we gotta go? Okay, so here we have 7i plus 3i minus 8 minus 6i. So what we're gonna have to do is we're gonna have to distribute this 3i to each one. So we have 7i, we're not doing anything with it yet. 3 times -8 gives us -24. 3 times -6 gives us -18. And then I times I gives us I squared. Okay, so I can go ahead and combine these two like terms. If you have 7 i's and you take away 24 i's, you're going to have a total of -17. And then we have to remember, we see an I squared there, so -18 instead of I squared, we do have to replace that with a -1. -18 times -1 is going to give you a +18. And that's it. Okay, the next one. So this one we have 2 minus 4i times -6 plus 4i. So we are going to multiply this in a box method. Okay, so we have 2, -4i, -6, and a +4i. And we start multiplying. So 2 times -6 is -12. 2 times 4 is 8i. -6 times -4 is a +24. And then I. And then 4i and -4i is going to give us a -16i squared. Okay, so we go ahead and write it all out. We have negative 12 plus 24i plus 8i minus 16i squared. But remember, whenever you see an I squared, you have to replace it with the negative 1. Okay, so all we got to do is simplify this. So we have negative 12, 24i, and 8i. We can combine those. Those are like terms. So that is going to give us 32i. Negative 16 times negative 1 gives us a positive 16. Okay, we're almost done because now that we multiply these two, that makes negative 12 and positive 16 like terms. So that is going to give us 4 plus 32i. That's it. Okay, the next one, this is 8 minus 3i squared. We're going to do the same thing. We're going to multiply it in a box method. So we have 8, we have negative 3i, we have 8, and negative 3i. Okay, because remember, 8 minus 3i squared is the same thing as 8 minus 3i times 8 minus 3i. So we multiply 8 times 8 is 64. 8 times negative 3 is negative 24i. 8 times negative 3 is also negative 24i. And negative 3 times negative 3 gives us a positive 9, and I times I gives us I squared. So we write it all out. We have 64 minus 24i minus 24i plus 9 because it's a positive 9. And instead of I squared, remember, whenever you see an I squared, you do have to plug in a negative 1. So 64 minus 48i, when we combine our like terms, these two are like terms. 9 times negative 1 is negative 9. So once you do that, 64 and negative 9 are like terms. So 64 minus 9 is going to give us 55. So 55 minus 48. All right. Complex conjugates is a pair of complex numbers whose real parts are identical and whose imaginary parts are differ only in sign. So here you have 4 and 3i. You have the exact same thing, 4 and 3i. The only difference is the negative in the middle. One is plus and one is minus. And that's it. The same thing with here. You have 2 and I. You have 2 and I. The only difference is one is plus and one is minus. Okay. So something special happens when you multiply complex conjugates. I know it sounds kind of fancy, but it's not too bad. We multiply exactly the same way that we did earlier. Here. So we have 3 and a positive 2i, and we have 3 and a negative 2i. Just let me write the 2. 3 times 3 is 9. Negative 2 times 3 is negative 6i. Positive 2 times 3 is going to give us a positive 6i. And then 2 times 2 gives us 4, so negative 4i squared. Okay, so the special thing that happens here first when we write this all out, 9 minus 6i plus 6i, and then minus 4. Remember, you can't write the I squared. You got to plug that in as a negative 1. So when we combine these two like terms, what happens is that they cancel each other. And all we're left with is 9. Negative 4 times negative 1 is a plus 4. And 9 plus 4 gives us 13. So what's special about it is that you take two imaginary numbers and you multiply them, and you end up with a real number. No imaginary numbers are left over. Okay. So if we look here on the next one, here we make our box again. We have 5 plus 3i and 5 minus 3i. 5 times 5 is 25. 5 times negative 3 is negative 15i. 5 times 3 is a positive 15i. And then negative 3 times 3 gives us a negative 9i squared. So then we go ahead and write it all out. We have 25. We have a positive 15i. We have a negative 15i. And we have a negative 9. And instead of I squared, we write a negative 1. So the same thing happens again here. These two terms cancel each other out. Plus 15 and minus 15, 0. And then we get 25. Negative 9 times negative 1 is a positive 9. And when we add these together, that gives us 34. And that's it. You end up with a real number. All right, so here we have x plus 3i and x minus 3i. So now we're putting x's in here, okay? Instead of having whole numbers here, we're going to put x's in here. And this is the section that we're going to need for our future assignment. So let me go ahead and write this. This part is very important. We have x and a positive 3i, and we have x and a negative 3i. So we multiply. X times x is x squared. X times 3i gives us 3ix. Negative 3i times x would give us negative 3ix. And then 3 times negative 3 gives us a negative 9. I times I gives us I squared. So when we write this out, we get x squared plus 3ix minus 3ix minus 9. Instead of I squared, we write a negative 1. Now these two end up canceling each other out, and we get x squared minus 9 times negative 1, which ends up being a plus 9. Okay, and that's it. This would be our answer, x squared plus 9. All right, the last one. Here we have x plus 5i and x minus 5i. So I go ahead and make my box. We have x plus 5i and x minus 5i. We multiply, we get x times x is x squared, 5i times x is 5ix, negative 5i times x is negative 5ix, and negative 5i times 5i gives us negative 25i squared. So when we write this, we get x squared minus 5ix plus 5ix minus 25 times negative 1. So we end up with x squared. The 5ix's cancel each other out, and we're left with negative 25 times negative 1 is plus 25. That's it. So thank you guys. Oh, there's still more. Okay, sorry. I thought we were done. So here we have 1 over 1 plus I. It says multiply the numerator and denominator by the conjugate. So remember, we already went over what the conjugate is. You're going to have the exact same numbers here. 1, 1, I. The only difference is the sign in the middle. Okay, and the reason that you multiply by the conjugate is to get rid of the imaginary number on the bottom. So remember how we had where we couldn't have a square root on the bottom? Well, the same rule applies here. You cannot have an imaginary number on the bottom. So we're going to go ahead and multiply these. All right. Starting with the numerator, we're going to go ahead and distribute the 1 to each one. 1 times 1 is 1, and 1 times negative I is negative 1i. Okay. On the bottom, we're going to multiply these two in a box. We have 1 plus I and 1 minus I. So 1 times 1 is 1. Negative I times 1 is negative 1i. Then we have 1 times I is a positive 1i. And then negative I times a positive I is going to give us a negative I squared. So we have 1 plus 1i minus 1i and minus, remember you can't write I squared, we have to write it as negative 1. So these two cancel out and we're left with 1, a negative and a negative make a plus, 1 plus 1, which is going to equal 2. So that's what goes on the bottom. We check to see if we can divide the 1 by 2, but we can't divide 1 by 2 or this 1 by 2. So it's just going to stay as 1 minus I over 2. Okay, remember the 1 in front of the I would be invisible. Okay, for reals, this is the last example. Okay, so to be able to get rid of the I on the bottom, the imaginary number on the bottom, we're going to multiply by the conjugate. So because this says 4 minus 2i, we're going to multiply by 4 plus 2i on the top and the bottom. Okay. So on the top, I can't distribute because I have two terms. I'm going to have to make a box for the top, and I'm going to have to make a box for the bottom. So let me go ahead and do that real quick. Let's make it a little bit smaller. So my box for the top will be here. My box for the bottom, I'll do it over here. So here I have 2 plus 3i times 4 plus 2i. So 4 times 2 is 8. 4 times 3 is 12i. 2 times 2 is 4i. And then 2 times 3i gives us 6i squared. So then we go ahead and write the whole thing out. So we have 8 plus 12i plus 4i plus 6 times negative 1. Okay, so 8 plus, 12i plus 4i we can combine, so we get 8 plus 16i. And then 6 times negative 1 gives us negative 6. Then we combine 8 minus 6 gives us 2 plus, my pen turned off, plus 16i. Okay, so that's what's going to go on the top. 2 plus 16i. Okay, now we're going to multiply what's on the bottom. So we have our conjugates. So 4 minus 2i and 4 plus 2i. So 4 times 4 is 16. 4 times 2 is 8i. Negative 2 times 4 is negative 8i. Negative 2 times positive 2 gives us a negative 4i squared. So I'm going to go ahead and write it all out. We have 16 minus 8i plus 8i. And then minus 4, and then instead of I squared, we write a negative 1. So we get 16. The 8i's cancel each other out, and we get 16 plus 4, because negative 4 times negative 1 gives you a positive 4. And 16 plus 4 gives you 20. So here we have 20. Okay, so we're just going to reduce these fractions. 2 divided by 20 would give us 1 over 10, right? 1 over 10 plus or minus, and 16 divided by 20 would give us, if we reduce, sorry, 1 over 10 plus or minus 16 over 20, we can divide both of them by 4, so this would give us 4 over 5, and that's it. All right, now we're done for reals, guys. Thank you guys so much. We'll see you next time. Bye.